Section 4.1, Fundamental Counting Principle and Tree Diagrams, Video 1. We will go over the following objective: solve problems using the Fundamental Counting Principle. Fundamental Counting Principle. The Fundamental Counting Principle can be used to calculate the number of ways in which a series of events can occur. The number of ways a series of events can occur is calculated by multiplying the number of ways each individual event can occur. Example 1. Iqbal would like to take 3 courses during the fall semester: 1 algebra class, 1 history class, and 1 speech class. There are 7 options he can take for algebra, 4 options for history, and 10 options for speech. How many different course schedules could Iqbal have, assuming there are no time conflicts among sections? So relating this back to the fundamental counting principle, we need to calculate the number of ways in which a series of events can occur. The series of events that can occur in this example would be the number of options he can take for algebra, history, and speech. So we need to multiply the number of options Iqbal has for algebra, which is 7, times the number of options he has for history, which is 4, times the number of options he has for speech, which is 10. Multiplying 7 times 4 times 10 gives us 280 options. What this means is that Iqbal has 280 different options for course schedules. Example 2. Soon Lee needs to choose an outfit. She has 8 pants, 11 blouses, 6 pairs of heels, and 2 purses to choose from. How many outfit options does she have? Again, using the fundamental counting principle, we would need to multiply the 8 options she has for pants times the 11 options she has for blouses times 6 options she has for pairs of heels times 2 options she has for purses. Multiplying 8 times 11 times 6 times 2 gives us 1,056. This means Soon Lee has 1,056 outfit options. Problems can become more complicated if more options are to be considered. As the following problems illustrate, the fundamental counting principle still applies. Example 3. Suppose an identification number has the format: 4 digits, then 2 digits, then 4 digits. The first and last digits cannot be 0 or 1. The rest of the digits have no restrictions. It is possible for digits to be repeated. How many identification numbers are possible? So we have 4 digits, then 2 digits, then again 4 digits. We have stipulations on what the digits can be. The first and last digits cannot be 0 or 1. That means the only digits possible in the first and last place of the identification number are 2, 3, 4, 5, 6, 7, 8, and 9. So there are 8 possible options for the first and 8 possible options for the last digits. The rest of the digits have no restriction, and it is possible for digits to be repeated, meaning the remaining digits of our identification number have 10 possible options. The 10 options are the numbers between 0 and 9. Using the fundamental counting principle, we will multiply 8 times 10 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 times 8 in order to get 6,400,000,000 possible identification numbers. Example 4. In how many ways can 9 students line up if the first 2 students are the 2 shortest, any order, and the last 2 students are the 2 tallest, any order? So we have 9 students that are lining up, and the first 2 students and the last 2 students have stipulations. So the first 2 students have to be the 2 shortest, any order. So the first spot, there are 2 options for students, and for the second spot, there would then be 1 option. Again, for the last two students, you have the two tallest students, any order. So the second to last position, you have two possible students that can be placed there, and for the last student, there is one possible option. Notice there are 9 students that line up. We've already accounted for 4 of the students. So there are 5 remaining students that can be placed in the 5 remaining spots in the lineup. So for the third position, there are 5 options. For the fourth position, 4, then 3 options, then 2 options, then 1. Multiplying using the fundamental counting principle, we have 2 times 1 times 5 times 4 times 3 times 2 times 1 times 2 times 1 to get 480 options. So there are 480 different ways 9 students can line up given the above stipulation. This concludes example 4.